All right, people, we start filing in. We'll get started. And yeah, so just have I'm going to go over the CASA learning that's due tonight. I doubt it's in the same order as yours because I don't know why it keeps making that mistake. But shoot me questions on Remind. I'll get started in about 3 minutes or so, get people settled and logged in, etc. So all these questions are from the CASA learning. There's like 30 of them. Yep, 30. Yeah. We'll take these one at a time. Field any additional questions you may have, and that's it. So we'll get started in a few minutes. So, people joining us, we'll get started in a couple minutes, going over the CASA learning from tonight. And, yeah, we'll get started soon. If you have any other questions, as usual, feel free to text me on Remind. Already got one question, which is good. Yeah. Hopefully everyone's having a good Monday night. Quarterly tomorrow, 30 multiple choice, 10 short answer. Blah-de-blah-de-blah. Almost there. Almost at break. A minute or two. Give people time to log in, get going, etc. Pull up the CASA learning. We'll take them a question at a time. May or may not be in the same order as yours. I will see. Alright, the stream's a little slow, but it'll get to you eventually. I'll get started in about a minute. And yeah. I'll try to get this uploaded on my teacher site. It takes forever for YouTube to like render the whole video, so I'll try to get it posted, but no guarantees. No guarantees. Okay. I'm assuming people will come in later, but I'm going to start with number 1. If you need me to go back or if you miss something at any point, just let me know and we can go over it again. It's no big deal. But start with number 1 here. Concentration. When you see that word concentration, it's going to mean one of two things. Either molarity or parts per million. The reference table and you go to the equations and you see the heading called concentration, the two things to the right of that are parts per million and molarity. So your brain should immediately go there as soon as you see that word concentration. especially if the wording of the problem clearly says something like calculate, or all the answers are numbers or something. So in this case here, we got parts per million because, well, all the answers are in parts per million. So we know we need to use that. And according to the formula, it's solute divided by solvent, both in grams. So grams of solute and grams of solvent. So your solute, sorry, not solvent. Come on, Mr. G. Solution. So your solute is what's being dissolved, which is basically thinking of any substance that's not water. Water is almost always the solvent in chemistry, unless the problem says otherwise. You can always think of water as a solvent. The solute is whatever you're dissolving, which in most cases is some salt of some kind or sugar. And you just take those two things. Our solvent here is silver chloride. Our solution we're given as 800 grams. And then you divide them, and don't forget to multiply it by 1,000,000. Most of you remember that in the test, which is great, that we took last week, but I told you people were going to forget, and people for sure forgot. And when you do that, I think the answer, actually, I need to figure this out. Divided by 800 times 1,000,000, I think it's 1.5. 1.5. Boop. Awesome. All right, so it's a basic parts per million problem. The only difference you might see is the problem might not give you this and give you the parts per million, in which case you get rid of this, make it your variable, 1.5 equals all this stuff. And then from there, you multiply the 800 and then divide by 1,000,000. And you'll get 1.2 times 10 to the negative 3 again. Those are the two types of most popular questions with parts per million. Take your time, watch your algebra, you'll be fine. Well, this next question's nice because it just tells you to go to table G. I always like when the questions tell you where to go. If table G, we'll pretend like it wasn't there. If you start seeing unsaturated or something about solubility, temperature, water, table G, every time. So you see something about saturated or solubility, you see mass, you see a mass of water, you see a temperature, your brain should think table G, if the problem doesn't tell you to go to table G. So we got, what's our substance? We don't know the substance, we're trying to figure that out. We want unsaturated, so we want this 80 grams to be under the line. So when we go to table G, we should see a bunch of lines, and then the 80 grams needs to be below one of these lines. People are doing this backwards again, where they're comparing the line. Let's just do this at table G. So we got 10 degrees, 80 grams. So here's 10 degrees. There is 80 grams right here. So people came up to me today and was like, Mr. G, there's like 3 of them that are unsaturated because you're comparing this to everything that's below it. You're comparing the line of the substance to the grams of the substance you have, and that's backwards. You got to compare the grams of the substance you have, the orange, to the lines above it. So anything that's above that orange dot at 10 degrees is unsaturated because I can keep adding and adding and adding and adding and adding more, and then I finally hit Ki. The most Ki you can dissolve in water, 100 grams of water, at 10 degrees is like 135 grams. So 80 grams is unsaturated. It is undersaturated because we are under Ki's curve. So the only possible right answer, hopefully it's a choice, which it is Ki. Stable electron configurations. The magic number is 8. Valence electrons is the last electrons in the energy level. And if we go to the periodic table, the ones that all have 8 valence electrons are group 18, noble gases. 8, 8, 2, 8, 18, 8, 2, 8, 18, 18, 8, blah, 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 8. So this was a periodic table question. Group 18 is the only one that is stable. All right, balanced equation. We want to know the mole ratio. So anytime you see a number in a formula, it's moles. So these big numbers, I want a highlighter. These big numbers here, there's a 1 in front of that O2, are moles. For every 2 moles of NO, there's 1 mole of O2. For every 2 moles of NO, there's 2 moles of NO2. So NO to NO2 is 2 NO makes 2 NO2. Well, that's 2 over 2, and that's 1, so it's 1 to 1. And you can even compare it in a formula. So if you were to look at just NO2, you would say, if we ignore the 2 here and just look at NO2, for every 1 N, there's 2 moles of oxygen. For every 1 mole of nitrogen, there's 1 mole of oxygen. Every number in a formula is moles. Every big number in an equation is moles. Pretty much, if you see a number, it's probably moles. All right, so this one, it's easier than it looks. Some of you start doing a bunch of conversions for this, but the big thing about a chemical reaction is mass and energy are conserved. Meaning you can't create and lose mass, you can't create or lose energy. It's conserved in some way. And if it's not conserved within the reaction, it's either absorbed by it or released by it in terms of energy. So if I have 46 grams of Na and 71 grams of chlorine, those can't disappear. Even if you do a lab and you are making sodium chloride from scratch, which I probably wouldn't do because it's pretty explosive stuff, and you're like, wait a minute, I had 10 grams of each, I only got 5 grams of product, Mr. G, you lied to me. You probably lost product or made a mistake or did something goofy where you goofed and you lost product somewhere. People do it all the time. It's really hard to get 100% of what you created. So, in any reaction, if you have the mass of... I don't understand that question. If you have the mass of 2 things out of 3, or 3 things out of 4, or 4 things out of 5, you can get the mass of the 5th one by just doing some basic math. So, 46 grams plus 71 should be 117. We have 117 grams of NaCl. And you can do the reverse. So if I give you the product of the reactants, you should be able to do 117 minus 46 to get back to 71 for chlorine. So just do some basic arithmetic. You'll be all right. I think you were trying to ask when the live stream ends. I'm going to predict around 9. It might even end earlier if no one has questions, because some of these are really quick. We just got to remind ourselves, wait a minute, where do I go on the reference table? Wait, what's a mole again? Wait, what class am I taking? Stuff like that. Exchange of ions between 2 compounds. So that's just like you have 1 compound here, 1 compound there, and then you get a double switch. A double switch is a double replacement. All right, trends in electronegativity of a period. So periods are the ones that go from left to right. These are periods. And that's labeled on your reference table. Now, I remember the trends. I know if you go from left to right, the radius is decreasing and the electronegativity is increasing. But you get there on test day, you already have so much information you need to know for so many classes. You're like, Mr. G, can you make this easier so I have one less thing to worry about? Go to Table S. Well, first of all, check your periodic table and see what elements are in Table 3. And pick the first one and the last one. And I would say pick the last one that's not a noble gas, because noble gases kind of throw off the trend a little bit. But I would pick Na, because that's the first one. And again, ignore the noble gases for the trends, because noble gases are going to report a 0 for electronegativity, and then that's going to confuse you a little bit. So I would say, don't worry about that. And chlorine, just pick the first one and the last one, and then just go to the next page and go to table S and find chlorine's electronegativity, which is, it's already highlighted, it's 3.2. And then find sodium's, it's 0.9. So that clearly increased from sodium to chlorine. And then the radius went from 160 for sodium to 104 for chlorine. That went down. You can look it up. Makes your life easier, one less thing for you to worry about. It's on the reference table for that reason. All right. Metal, metalloid, and a non-metal. So back to the periodic table. Which ones are the metals? By now we should be good here. I'm not going to dwell too much on this. We should know where the metals are. Metals are anything this way, metal. Non-metals are anything this way, non-metal. And then what I'm highlighting are the metalloids. It's the staircase, and you ignore aluminum. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Sometimes they count acetine, sometimes they don't. You typically don't see At too much. So you want to find in that list an element that's to the left of the staircase, an element that's to the right of the staircase, and then an element that's on the staircase. And when I go back to the answers, I believe, giving it a quick look, it should be answer choice 1. 4 does not have a metal in it. Those are all non-metals. It also doesn't have a metalloid. We got non-metal, non-metal, non-metal. 3 has metal, metal, non-metal, gone. 2 has metalloid, metalloid, non-metal, gone. All right. 9. This is a big misconception. Now, 9 was pretty gracious because it gave you the energy over here. So it was clearly saying energy was going into the reaction, not coming out of the reaction. So energy was being absorbed. So this reaction just straight up told you that. So 3 and 4 are incorrect because they say energy is released, which you're not seeing. Released is to the right of the arrow. The after. Energy being absorbed is before the arrow, the before. So you basically just needed to read the equation properly for this one. And based on what I can see, I see 1 H2 making 2 unbonded H's. So I see 2 H's on the right. Should be answer choice 2. There's a good chance, to give you a little hint, that this won't be there tomorrow. In which case, we go back to way before midterms, where the clap break rule applies. If you take 2 things and join them together, you hear that energy being released in the form of sound. Like I can hear the clap. So 2 things release that energy. If you take a pencil and you break it into 2 pieces, you have to input energy into that pencil for it to crack. That pencil is absorbing energy to crack. So if you're breaking bonds, you're absorbing energy. If you're forming bonds, you're releasing energy. Now, as hard as that solution test was, I was actually pretty happy with the results and how they came out. Not that everyone did stellar, not that everyone's going to get 100, but given that topic and how difficult it tends to be from year to year, I was pretty pleased. And if there was one thing I think your biggest weakness was, it was questions like 10. You were pretty good at knowing you dissolve something in water, the boiling point's up, the freezing point's down. Using the molarity equation, for the most part, was okay. Couple algebra mistakes. Maybe you forgot to convert to liters. You're being silly. Table G, unless you manipulated that water amount to 200 or 50, usually you are good. But how can we figure out what substance is going to raise it the most? And there's two main principles. Ionic is better. So something with a metal in it will always do a better job than a completely non-metallic compound, aka a covalent compound. And then more is better. So I would do this first, the more is better part, because it's really easy to eliminate those answers. And 1 and 2 are gone, because these are each 1 molarity KCl, 1 molarity CaCl2. 3 and 4 are 2 molarity, 2 molarity. Now I would do the more is better for the context of this problem, because when I look at all my answer choices, it's either KCl or CaCl2, and K is a metal, and Ca is also a metal. So I didn't have to worry about the ionic is better part for this question because they're already all ionic. More is better applies in 2 ways. The molarity or moles, depending what unit they give you, and once you've determined, like I've got it down to 2 ionic compounds, the ionic compound that has more stuff in it, more atoms, will do better than the one that has less stuff. And in this case, CaCl2 has 3 ions, KCl has 2, KCl is going to win, or lose. CaCl2 is going to win. Alright, we got to backtrack a minute. Question on 9. If it's the other way around and energy is released, would it produce 1 mole or 2 moles of hydrogen? So, if we go back to 9, literally take that arrow and point it the other way. You would release energy and make 1 H2 because there is a 1 mole of H2 there. Good question. So flip the arrow around, 2 things become 1, energy is released. 11. What type of reaction is that? I see a compound here, 2 different substances. I see a single substance here. It's 2 Fs, and I get that, but it's the same thing. There's not 2 different substances. It's 2 of the same. And one of those Fs, based on what I can see, is coming in and kicking off I, making this a single switch, single replacement. And to determine if the reaction occurs, if you see a question in like 11, but it was worded like, will this reaction occur? Which one of these elements will allow this reaction to occur? Something like that. That is a Table J question. So Table J is a big single replacement reference table. And if we look here, F2 was alone, I was in the compound. I already forgot what the compound was, Ki. So since F2 is higher, F2 is more chemically active, and therefore this reaction will occur because F has the strength to come in, kick off iodine, and bond to K in its place. 12. This is a stoichiometry question. We are concerned with H2O and NH3. So I'm going to cross this out because I don't want to get distracted by other elements or compounds in the problem. And from the reaction, for every 4 NH3, there are 6 H2O. That's what I see here. Stoichiometry, that principle is all about what happens if I change those coefficients to some other number. How will it change the coefficient in another compound? And here I am changing the moles of NH3 to 2, which is the moles of H2O to what? Some of you might see it right away. If you don't, cross multiply and divide. 12 equals 4x. Divide by 4. Divide by 4. X is equal to 3. If you didn't cross multiply, or what do you mean, Mr. G? People can see that right away. Some people can just pick up fast that 4 divided by 2 is 2, and so 6 divided by 2 is 3. I'm not asking you to see that right away. Set up a proportion, cross multiply and divide, and you'll be fine. Don't stress about these problems. They're much simpler than it looks. The issue is mainly reading comprehension. Like, if you don't read the question, or you don't take the time to comprehend what the question's asking, you're not going to get it right because you don't know what the problem is. And I tutor the SAT a lot, and that's the biggest issue we tend to have with student scores being below their expectations. They don't answer the question because they don't really read the question. And I'm like, how do you expect to know what this passage is about if you didn't read the question? Or how can you answer this math question if you didn't read what it wanted you to do? So take your time with these. You're going to have plenty of time tomorrow. It's 40 questions. Take your time. Don't rush. All right. 1.5 moles, mass. So there's 2 equations on the reference table that have the word moles in it. If it has mass in it as well, you're probably going to gravitate to the moles formula because moles formula has the word mass. And if you don't know the unit for mass, it's usually going to be grams. Gram formula mass is periodic weight. I should just say periodic mass. Periodic mass. So the weight from the periodic table. Add up all the atoms. How much does it weigh? Oh, it's more than 1 mole. It's less than 1 mole. That's what you're trying to figure out. The other one that has moles in it is molarity. But typically when you're dealing with a molarity problem, you'll notice, wait, mass isn't in this question. So if you're not sure which moles formula to use, does it have mass or does it have volume? Because volume is liters, which is the molarity equation. Mass is grams, which is the moles equation. So it is 1.5 moles. That was given. You were not given a mass because the formula is given over gram formula. I wasn't given a mass. I don't know what the mass is. But carbon dioxide, if you look it up on the periodic table, is 12 plus the 2 oxygens are 16 each. That's 44. Cross multiply, 66. Noble gas, group 18. Neon is the only one in group 18. Ammonia is not an element. Chlorine's in 17 and nitrogen's in 15. So, no. Solubility. How can you figure out which one this will combine with to make something that is soluble? I am going to go to my reference table and check which one of those are soluble, which is table F. Solubility rules. These are soluble. These are not. These are not. These are. So these are the AQs. This is solid, solid, AQ. So let me go back here because I got to copy down which ones we had. Sulfur, OH, CO3, SO4. We have to figure out which one is soluble. Now, if I remember my solubility rules, which I'm trying to on the top of my head right now, it's either 2 or 4. Hey, okay, so actually 2 or 4 is a good one to bring up. So I'll do the other 2 first. Carbonate is insoluble always unless it's with group 1 or ammonium. Barium's in group 2. It's Ba. Cross that out. That is not soluble. Sulfides are not unless they are with group 1 or ammonium, which we just determined is not barium because it's in group 2. Cross out S. Sulfates are always soluble unless, there's barium. Barium and sulfate don't go together. They are not soluble. If you form that compound, I shouldn't say they don't go together. They can bond, but when they bond and you try to dissolve it in water, not going to work. Hydroxides are not Hey, what are you doing? Unless, hey, barium's an exception over here. Barium and hydroxide will be soluble. So, Ba and OH are soluble. All right. Another quick one. When you get questions like this on tests, especially in June on the Regents, these should be gimmies. Don't make a silly mistake on questions that are quick. What is this? Just identify it. Take a look. We got lithium. We got nitrogen. They're combining. That's synthesis. If you send me a text on Remind, because I think my feed lags when you see it, so I might be ahead of what you're watching, and sometimes you can pause and like rewind and whatever. Just tell me what number you're stuck on, because it makes my life and your life a bit easier. I think whoever's texting me, you want me to do 15 again, the one right before this. So let me do a couple more down here, and then I'll circle back to 15 later when we hit another one that's soluble, which, if I'm looking correctly, is 19. So I'll go back to 15 in a sec. All right, percent composition by mass. Part over whole times 100. That is on your reference table. It is called percent composition by mass. Stop making the whole 100. You guys are actually like really good at doing it within a compound, like 17. But when it comes to those ones where it's like you mix these two things together, you always want to say it's 30 over 100, 70 over 100, 90 over 100. When it's not. It's 90 plus 100, 70 plus 100, etc. So it wants the percent by mass of oxygen in this formula. When I look at this formula, that 2 you distribute to everything within the parentheses, and distribute means you will multiply it. So you have 6 oxygens in there. So oxygen weighs 16. That is my part. It gave you the whole. Apply it by 100 when you're done, because you need to make it a percent. And if I'm doing that in my head rather quickly, it feels to me that the answer is going to be 4. 96. Yeah, 96 is over half of that. That's 4. Uh, 15 was the one with table F. I know you're probably talking about 15. I'm going to go back to 15 after I do 19 because they both use table F, so that way we can hit it twice. But I see what you're saying. I think you want 15, which was table F. Okay, so this one uses that same principle that if you are given all the information about everything except one in the reaction, use all of that information and just do some addition or subtraction. If you have 4.5 moles of oxygen and 3 moles of aluminum oxide, you should just be able to use those numbers and do a little bit of work to get the aluminum that's left over. But there's like multiple ways you can do this. First, the oxygen went from 3 to a larger number, which is 4.5. The aluminum went from 2 to a larger number, which is 3. So the aluminum must also be increasing, because if you're increasing all of them, you must be increasing the aluminum as well. The other thing you can do is this is just like a stoich problem. So when you're given moles, no, this is not mass. This is not mass. What's up?
Harper just wanted to visit.
Harper?
Go in your crate.
Come here, girl.
I'm leaving, so she was wanting.
Come here.
Girl.
Hey, are you just going to ignore me? She doesn't care about me.
Yeah.
Oh, hi. Yeah, I'm here.
Lay down.
Whatever.
Lay down.
You can't do the like addition and subtraction you did with the other problem before. With oh man, where is it? How far? With 5. Like 5, we did like, oh, we have that much mass of this, that much mass of that. Just add it together, subtract it. You can't do that with moles. So you got to pick one and just do a quick proportion. So from the reaction, 4 ALs make 2 Al2O3s. How many ALs, that's a 4, will it take to make 3? And you cross multiply and divide, and you get 6 again. So multiple ways to solve this problem. All right, 19. Again, kind of long. Not that long, though. Don't be complaining and say, this is a really long word problem, Mr. G. This is not that long. Okay, you're mixing something in water. You thoroughly mix it, and then you can separate it using filtration. If you can separate it using filtration, aka filter it, you have a heterogeneous mixture. And heterogeneous means insoluble. Insoluble. So this tells you to go to table F, and you have to look at these 4 answers. Notice they're all bonded with chlorine, so we're going to go straight to chlorine, and look at which one of those is not soluble. See you, Harper. Nice to know you. So I go back to the reference table, and I'm going to look on here, and I'm going to find chlorine. Chlorine is always soluble unless it's with these 3. These 3 make it insoluble. These 3 make it heterogeneous. These 3 make it able to be filtered out. Ag is one of them. The answer is AgCl. Take a deep breath. I'm going to piggyback to 15 again. Now would be a good opportunity to take maybe a quick break, go get a drink of water, look through the ones I already went through, and say, wait a minute, I didn't understand how you did 2. Can you do 2 again? Shoot me a text on Remind, and I'll do 2 again, just for you. All right, 15. How'd I do 15? I did 15 the exact same way I just did 19. I am concerned about barium. I am concerned about its solubility, which is going to be table F. And I want it to be soluble when it bonds to one of these 4 things. Why do I keep saying 3? So I need to find these 4 things on table F. I need to find what happens when they bond to barium. And if they're soluble with barium, that's the correct answer. With me? So, we got S, CO3, OH, and SO4. Those are my 4 options. SO4, is it soluble with Ba, barium? Sulfate is soluble unless it's with, would you look at that, barium. So it's insoluble with barium. It does not dissolve in water when it is with barium. No. Carbonate is insoluble unless it's with group 1 or NH4. Barium's in group 2. Barium and carbonate will not dissolve in water. They are insoluble. No. Sulfide is insoluble unless it's with group 1 or ammonium. We just determined group 1 and ammonium is not barium. No. Hydroxide is insoluble unless it's with, oh, would you look at that? If it's with barium, it's an exception to being insoluble. And if it's an exception to being insoluble, it is soluble. And if it is soluble, it answers the question. So you're going to come here and you're going to put OH. 20. What is the gram formula mass of FeNO33? So, that is asking you to add up the weights of all of these elements in this compound. We have 1 Fe that weighs 56. We have 3 nitrogens that weigh 14. And we have 3 times 3, 9 oxygens that weigh 16. I feel like if you add those all up, you get 242. Because 9 times 16 is 160 minus 16, which is 144. Plus 56, we're already over 200, so it's got to be 242. And that was exactly 200. And then, yeah, plus 42. All right. 21. All right, 21 we almost did, but instead of ionization energy, we had atomic radius. I forgot when we did this question. It was like one of the first ones we do. So anytime you see these trends, you think table S. Well, how do you put number 1 into your calculators? Is that what you're asking? How do you put how do you do number 1 in your calculators? In the blue calculators. Oh, how you do, I see what you're saying. So how do you do scientific notation in your blue calculators? Person who asked that, you should know how to convert numbers out of scientific notation. But if you forget, it's times 10 to the negative 3. That's the same as, so if you see times 10 to the third, you're multiplying it, get out of here. No, stop. Wow, okay. I'm just going to do it down here then. If you see 10 to the third, that's multiply it by 10 3 times. If you see 10 to the negative 3, the question was, how do you put number 1 into those blue calculators that suck and can't do anything? Because it's in scientific notation and you can't put exponents. And usually I would say it's scientific notation, you should know this. But if you do 10 to the negative 3, it's the same thing as dividing it by 10 3 times. So you could do that. General rule of thumb is if you have the... No, I'm not going to say it. Never mind. I think it'll just confuse you more. Question was, how do you know what atom has the strongest attraction to electrons? We actually went over that one in class, you silly goose. Electronegativity. Check table S. The atom with the strongest electronegativity, which is on table S, has the strongest attraction for electrons. So this one you can check table S again, look at Na, look at Cl, find these two things, and see what the trend is. You'll find that they both increase for this. 22, take that compound, break it in half, you absorb energy. The bonds are clearly breaking because you have one thing bonded together to two things not. The end. Sulfur is S, which is to the right of the staircase, making it a non-metal. Non-metal. Oh, right. So, much like the reaction we just saw in 22, one thing, because that's a compound, you say there's two words, there's no plus sign, so one compound breaking apart into two separate things that are different than what you started with is decomposition. This is bringing things together. These both, 1 and 2, have two items on the left side, something plus something. So if you see something plus something on the left, it's 1 or 2. If you see just one thing on the left, it's decomp. Most similar chemical properties, same group. So, as much as you want to say, I remember some of the answer choices. As much as you want to say, oh, it's got to be N, O, and F because they're right next to each other. Or it's got to be these guys because they're right diagonal from each other. No. Same group. Are they all in group 17? Are they all in group 16? Are they all in group 15? Are they all in group 4? Those are the ones that are chemically similar to each other, which, to my knowledge, is 3. Those are all in group 2. It goes Mg. They skipped calcium. Strontium and barium are towards the bottom. All right, balancing equations. So I'm pretty sure I actually give this to you as a short answer question and not multiple choice. If you have a multiple choice question and you don't know how to do it, yes, when it's milliliters, you divide by 1,000. Good question. If it's multiple choice and you're stuck and you like keep getting an answer that's not there, take all these answers and plug them in until it's balanced. That's another really great SAT strategy, especially on the math section when possible. If it's multiple choice, the answers are there. If you know the formula and you like don't know where to start or you're stuck, just plug the numbers in until it balances. Based on everything I see, you have 12 times 2, that's 24 O's there. 14 times 1, that's 14 O's. That's a total of 38. What times 2 is 38? 19. Ooh, a couple questions. Woo! So, milliliters. Someone asked, if it is milliliters, do you divide by 1,000 to convert it to liters? So if you have 500 milliliters, divide that by 1,000, you get 0.5 liters. So yes, remember that. People are confirming that the video is 15 seconds behind the audio. Oh, that sucks. So if the audio's off, I am just going to say I'm sorry. I think if you try anything on your end, I can't hardwire my laptop. My laptop doesn't even have an Ethernet port, so I definitely can't hardwire it. If it's off, that's unfortunate. Is decomposition always absorbing energy? Yeah, as far as you know. Because anytime you break things apart, you need to absorb energy. So I would say yes. Okay. I'm not going to overly concern myself with these unless it's a noble gas, but it can't hurt, I guess. Group 1 are your alkali. 2 is alkaline. 17 is halogen. And 18 is noble. So radium is RD, RA. Alkaline earth metal, it's in group 2. Neon's in group 18. Potassium's in group 1. Fluorine's in group 17. I would know the noble gas is group 18 and leave it there. Empirical molecular formula. Empirical is reduced. Molecular is actual. So when I look at 28, I count 1, 2, 3, 4 carbons. 1, 2 hydrogens. 2 nitrogens and 4 oxygens. So gone. And then to reduce that, if I divide them all by 2, I get C2H10O2. Boop. 4. Yeah. Again, I apologize if the feed is off. That's just the worst. Useless information. Useless information. Ascorbic acid has a molecular formula of C6H8O6. Divide that by 2, and you get 3, 4, 3. 343. Molarity. Molarity. So the equation for that's on the reference table. The equation for molarity, which is big M, is moles. 4 moles per 2 liters would be 2. That's it. That is the CASEL learning. So again, these were all multiple choice. You know you're going to have some short answer tomorrow. If it says explain in terms of, use the darn terms. Use it somewhere. Say the word somewhere in your answer. Even if you're not sure if you're using it right, you're guaranteed to get it wrong if you don't use the words at all. So if you're like, oh my god, explain in terms of molecular polarity. I don't know. I don't remember what polarity is. I don't know what to say. Just say polarity in your answer. Because you know what? If you don't, it's wrong anyway. Oh, hey, welcome back, Harper. So nice to see you. You gonna ignore me again? Hi, yeah, you wanna come here? Hi. Yeah, if you knew how like cameras work, I could tell you to like look at the camera, but you don't. Oh, there you go. You wanna come back? Come back for more? Come here. Yeah. Woo! Alright, come here. Look at the camera. Say hi everybody. I'm Harper. I don't understand how cameras work. I'm gonna look at Mr. G. Yes, hi. Good girl. I'll be with you in a sec, alright? I'll let you out in a minute. If you got a question, send them to me now, even if they're from the problematic assignment, because I think I sent that to myself. Maybe. This wants to load. Whoa. Alright, yeah. Let's open this in Notability. Leave this open for like a minute. If I get a question on the Castle, not the Castle Learning, the review I passed out today, we can do a couple from those too. If not, then that's it. So I'll wait, see if I get anything, and then if not, I'll just see you guys tomorrow. Let's see, did I get any more messages? Nope, doesn't look like it. Five. Determining the number of moles of carbon dioxide. So you got to do a little bit of reading here. It was a big puzzle piece, but somewhere in this giant paragraph it said you had 340 grams. That's given to you, that mass. So you do given divided by actual, and you get moles. It's like 7.7, something like that. I think the acceptable range of answers was like 7.7 to 8. I don't know why they would accept 8. That's clearly over. But I guess if you round to sig figs, 8.0 is acceptable. Yeah, that's it. So the key here to 5 was just searching through here and just knowing that this is useless. Useless. Oh, I need that. Okay. Because for moles, you need grams. As far as you know. All you need for moles is grams. Oh, hey. What is going on? My phone's like not sending me anything. It's okay. I switched it over to the laptop and that worked. Good to know. I'm not going to be in school tomorrow. Can I take the quarterly not tomorrow? The answer is yes. If you're not going to be here tomorrow, or if you have something going on, or whatever, I don't care. You need to take it at some point. Stop by whenever you're free, and I'm free, and you can take it. Like I said, I'm blocking off this whole week. I'm staying after school every day. Because, you know, it's been third quarter since January. some people in my third block have to make up a lab from January. You can't rush these things. Can't rush these things. Let's see, what else? Number 4 on the packet. You got it. I'll do that in a sec. Whoop, drop my phone. It's all good. It catches up, so it's easy to follow along. Excellent. All right, 4. Oh, balancing. All right, so I picked a strange one in this packet because usually the advice I give is to do oxygens and hydrogens last. And it actually made it harder if you tried to do the carbons first in this one. I'm being totally honest. So, carbon 6, hydrogen 12, oxygen 6. That's easy to see. Carbon on the left is 2 plus 1, 3. Hydrogen is 5 plus 1, 6. And oxygen is 1 plus 3, 3. So, is this not number 4? This is 4. So, I'm doing number 4 in the packet. If you want number 4 somewhere else, let me know. So, in this case, the easiest one to start with is actually hydrogen, because hydrogen pops up once here. When I say once, I mean it's in one formula, and it pops up in just one formula there. So when it's a 1 in 1, pick that one first. Usually, the general rule I gave, which is oxygen and hydrogen's last, usually works. So I got to multiply this by 2 to get 12. 2. So now my carbons are now 2 times 2, 4, and 1. They're 5. And then the oxygens are 2 times 1, which is 2, plus 2 is 4. So now I can balance the oxygens, because I can put a 2 here, and 2 times 2 is 4, plus 2 is 6. And the carbons now go from 2 times 2, which is 4, plus 2, which is 6. And that's balanced. Take your time with balancing. Count. If you can count, you can balance. If you count and it's not balanced, you goofed. Change a number. Molarity. So I'm going to take that general question of do a molarity problem and find one in here that's molarity. Oh, hey. Yeah, I can do 11. We're going to do 13 first. 13 is a molarity question. Molarity is moles per liter. 1 mole. 1. 2,000 liters. Divide that by 1,000, and you get 2. 2.5. That's molarity. If they don't give you moles, convert to moles. Like if they say, oh, what if this was 50 grams? Well, that's your given mass. That's your actual mass. Divide the 2. Do 50 divided by CaCl2's actual weight, which is like 100. 110. But usually they're pretty forgiving with moles. I'm going to say dilutions I'm not going to put on there. I don't want to worry about dilutions. So 14, the dilutions, no. 11, which compound decreases in solubility, temperature, probably a table G question. So you're going to go to table G, and you're going to look for something on where is notability? You're going to go to table G, and you're going to look for something on table G that has a slope going down, because that means the solubility is going down. So it said 10 to 50, right? So if you look at table G, like 90% of them are going up, up, up. HCl is always going down. NH3 is always going down. And SO2 is always going down. So those are your only answer choices. HCl, NH3, or SO2. And NH3. Because NH3 is a gas, and you want to keep gases contained, high pressure, in the refrigerator, low temperature, or else they will leave the soda can. What else we got? Any other questions? So number 4, I did. Molarity. Number 11. So here's a fun science lesson. If you spin someone around really fast and then you look at their eye, like I'm not going to do it because I have to do it pretty fast for a quick amount of time. But if you spin someone around really fast and then stop them and hold them still, their eye is going to go like this. That's cool stuff. That's what you learn in college. Anyway, any other questions before we call it a night? What do you think, Harper? You have a question? No, I'm just gonna sleep. That's all she does. Sleep. And dig in the yard looking for things to eat, ruining my lawn, Harper. What are you gonna say about that? Nothing. Classic Harper. It's time to play HQ. That's not a question. I also hate you, HQ. You trick me, and I lose every time. You know, I'm surprised. It's almost 9 o'clock, and I know people who are watching me right now asking questions, and I have yet to get, and I'm going to say that now, I have yet to get Fortnite stupidity. Is that going to be on the quarterly? I'm assuming that's referring to information about my dog. Maybe like, what's my dog's name? That might be on the quarterly. Unless that was a serious question, in which case I don't know what that's in reference to, so you need to be more specific. But you never know. You never know what's going to pop on that quarterly. Might be a question about Harper. What are the 4 breeds that Harper is according to a DNA test that we got of our dog? And yes, we got our dog DNA tested. And no, I don't care if you judge me for it, because I thought it was awesome. Harper, what are you? Do you even know? You don't know, because you're a dog. That chair spin. Oh. No. That will not be on the quarterly. Do you even know what that's called? It's called nystagmus. You can look it up. It's actually, the Wikipedia has a, I say GIF, not GIF, but Wikipedia has a, because I just Googled it, has a GIF of it. Look at that eye. Boop, boop, boop. Some people that just happens to, like, naturally. Like, they just can't control that, which is unfortunate. Voluntary? What? Who is doing this voluntarily? Alright, I'm going to give it like a 30-second countdown, and then I am ending this. Harper, who's home? Who's home? You're a great guard dog. Do you know that? You're just staring at me. What do you want me to do? Why don't you go say hi? Yeah,
Oh,
there
now
you
you
go.
get up?
Yeah. Oh, yeah. I hear plastic. You got food? I'm coming.
Once she knows it's me, she comes.
No, I love food. Mrs. Hughes, a few of your students checking this out right now.
What?
There's a few of you, your former and current students,
What?
checking out this live stream, which has devolved into talking about Harper and nystagmus. Huh?
Because she's awesome.
Oh, yeah, she's the best.
Who are my people right now?
Michael
Hey, Michael.
gave me a quick shout out on Remind. Sully from last year,
What up, Sully?
checking it out. I don't know if they're still there.
Okay.
Loretta sent me a text,
But
I don't know if she's watching the live stream. She
Okay.
sent me a text to let me know she's not taking the quarterly tomorrow because
Cool.
she won't be here. That's all I know.
it must be fascinating for people that are still on with you.
Yeah, I spun around in my chair a little bit and then told them what nystagmus was.
What is that?
It's when your eyes go like this
Oh, okay.
because it's like
Yeah.
you're spinning on an axis.
Yeah.
So it's tracking your movement, and so it's keeps tracking after you're done, and so you like realign.
It's cool.
Yeah. All right, we're done. I got no more questions.